Hello everyone. Today we're going to look at using Excel to find normal distribution probabilities and percentiles. So first we're going to look at the standard normal distribution. So we're going to assume that Z is normally distributed with mean 0 and standard deviation 1. So it's again a standard normal distribution. Just like with the other types of probabilities in Excel, the binomial, the Poisson, we have them in terms of the probability of Z being less than or equal to a number, or the height of our normal distribution, which is kind of equivalent to the probability that Z equals a number, but not quite. So for the first one, the probability that Z is less than or equal to 1.5, if I want to use Excel to find that probability, I would type something that looks like equals, because again we need Excel to do the math, norm for the normal distribution, dot S because it's the standard normal distribution, and then dot dist because we want the distribution. So norm.s.dist returns the standard normal distribution, has a mean of 0 and a standard deviation of 1. So don't forget that it will always tell you right here what it is that you're using. So now open parentheses, and then it wants Z and then comma cumulative. So Z is my value in my probability, so 1.5, comma, and then here we have that true false like we did with the binomial and the Poisson. True, remember, can also be a 1 and false can be 0. True says it returns the cumulative distribution, which is the probability of negative infinity up to my Z value, which is exactly what I want. The false says it returns the probability density function, which is the height of our normal distribution, which will not be useful to us in this class. So we're never going to use the false, we're always going to use the true, which again I can do as a 1. And it gives me a value. And I'm going to type it back in here without the equal sign so that we have it and we know exactly what it was that we plugged in. And then probability in math mode, this is exactly the same thing that I have, but we'll see it be different in a little bit. Okay. So that's how you would do the probability of Z being less than or equal to something. If I have the probability that Z is greater than a value, I need to change it to be less than or equal to, and I do that by looking at the complement. So the probability that Z is greater than 1 is the same as 1 minus the probability that Z is less than or equal to the 0.9. So we're going to use complements here. And then to plug that into Excel, I'm just going to do 1 minus norm.s.dist, my new Z value, 0.9. And then again, it's always going to be a comma 1. So I'll type it over here with the equal sign so that we get a number out. 0.9, comma 1, and we get roughly 18%. If I'm looking at the probability of Z being between two numbers, we've talked about this before. If I'm looking at Z being between two numbers, that's going to be a probability minus a probability. And it's always going to be the probability of the larger one, which was our 1.2, minus the probability of Z being less than or equal to our smaller number, our 0.75. So I have a lot of people who will switch these around because they'll do the 0.75 minus the 1.2 because that's the order it is in the single written probability. But remember, it's always the bigger one minus the smaller one. If you do it in this order, you'll get a negative number, and probabilities cannot be negative. And that just means you probably switched the order. Okay, so if I put it, again, for now without the equal sign so that we see what I'm typing, it will just be norm.s.dist, and then the first number, the 1.2, comma 1, minus norm.s.dist of our second number, comma 1. So that's the same exact thing that I'm going to plug in over here, but put the equal sign so that I get a number out. Okay, so it's the same thing. I'll hit enter. Oops, something happened. Oh, forgot the period over here. So if you ever have that hashtag name, that just means something happened when you were plugging it in. So I go back up here, and then I notice I didn't put the dot in. So now I have the number. So this one, B8, is going to be the same thing. Remember that with things that are continuously distributed, that the equal sign doesn't matter. So whether or not I had less than or equal to, or strictly greater than, it's not going to make a difference if it's continuous. If it was discrete, like the binomial and the Poisson, it made a big difference, but it doesn't here, which is kind of nice. So again, here I'm going to have the two different probabilities. Start with my bigger one, the probability that z is less than or equal to 0.5, minus the probability that z is less than negative 0.5. And then if I was going to type it into Excel, again, I'll do it without the equal sign so that we can see it. Here's my first probability, norm.s.dist of 0.5, 1, minus the second one. So remember that the first one is positive, the second one's negative. And then I'll do it again with the equal sign. And make sure I'm putting all the periods in there that I should be. 0.5, 1. So I'm getting roughly 38% of the values are between negative 0.5 and 0.5. Okay. So let's see how this changes if I'm not looking at a standard normal distribution. So I'm going to bring this down. And here we're going to look at x, which is normally distributed with mean 25 and standard deviation 10. So I have similar problems here. I have a less than or equal to, I have a greater than, and then I have between two values. So for probability mode, it's going to be the same that we had up there, except instead of a z, we're going to have an x. So if it's less than or equal to, that's what I want. If I have greater than, I'm going to change it so that it's going to be less than or equal to. So the probability that x is greater than 40 is the same as 1 minus the probability that x is less than or equal to 40. And then just like before, for the probability that x is between two values, I'm going to use a difference of probabilities. Oops, and I put the wrong one down. So again, make sure you start with the bigger one. So it's the probability that x is less than 50 minus the probability that x is less than or equal to 30. For the second one, it's the probability that x is less than or equal to 35 minus the probability that x is less than 15. Okay, so again, these are the same type of problems we had with the standard normal curve. The difference is going to be in the Excel command. So here I don't want the standard normal, so I'm going to do just equals norm.dist. And it says returns a normal distribution for the specified mean and standard deviation. So I'm going to have to tell Excel what mu and sigma are. So if I open it, I see x, so there's my 15, comma, then the mean, my mean is 25, comma, standard deviation, my standard deviation is 10, and then again it's the cumulative. True or 1 will give me the cumulative distribution from negative infinity up to 15. False will again give me the probability mass function, which is the height, which again we don't want. So I'm always going to do comma 1 at the end. Okay. Then we get about 15.9%. And again, I'll put it up here so that we see what it was. So it was norm.dist, the x value, the mean, the standard deviation, and then a 1. So you have to include in here what the mean and standard deviation are. So those are going kind of in the middle. For the probability that x is greater than 40, we're going to have the 1 minus norm.dist, my value, my mean, my standard deviation, and then 1. And again, I'll do it over here with the equal sign so that we get a value. And don't forget, this will always tell you what it is you need to plug in. So as soon as I hit that open parenthesis, this pops up, and I know that my first one is x, and then my next one is the mean, then the standard deviation, and then the cumulative, which is the 1. Okay. So we get 0.84, so a good chunk of the values are greater than 40. So if we're between 2, I'm just going to do norm.dist, my big one, and then minus norm.dist, my smaller one. I'll make that a little bigger. And then I'll do the same thing with the equal sign, again, so that we get a value. Okay, so I'm typing in the same exact thing, just with the equal sign, and I get roughly 30%. And then for the last one, I'm going to make this a little faster. I'm just going to copy and paste this, and then change my x values. So my first one is a 35, my second one is a 15. And again, I'm going to copy and paste it, but with an equal sign in front. So we get about 68%. Okay, so this is how you would use the normal distribution finding probabilities. It's either norm.s.dist for the standard deviation, standard normal distribution, or norm.dist if it's not standard. You could also, if you wanted, standardize it over here. So I could change the probability of x being less than or equal to 15 to the probability that z is less than or equal to something, and then use the norm.s.dist. Or I could also, for the standard normal, use norm.dist and always just plug in the fact that the mean is 0 and the standard deviation is a 1. So I can just pick one and use that every time. Okay, so the next thing I want to look at is looking for things like the percentile or the z-score, or the z sub alpha or x sub alpha. So if I want to find a percentile, then the command that I'm going to use, I'm going to assume right now that we're looking at the standard distribution, is going to be equals, I'll put this over in the value, equals norm.s, because it's still the standard, because again I'm looking at z. And then instead of .dist, I'm going to look at .inv. INV stands for inverse, so it returns the inverse of the standard normal cumulative distribution. Again, it's reminding you that it has a mean of 0 and a standard deviation of 1. So the inverse is undoing the probability. So I want to know the z-score given the probability. So this is by definition the inverse. I'm undoing what I would have done with the distribution. And if I do parenthesis, it tells me to plug in my probability. So just like with the table, the probability is the area to the left, or the probability to the left, which is exactly what the percentile is. So I want the probability. I'm going to change 20% to a decimal. So I'm going to do norm.s.inverse, or INV, of 0.2. That's going to give me a negative z value, which we would expect because we're less than 50%. And again, over here, I'm going to plug in what I did. So norm.s.inv of 0.2, and I'll make it bigger. So this is what I plugged in, just with the equal sign. Okay. We'll do the same thing for the 85th percentile, but instead of 0.2, it's 0.85. So that's going to be the only difference there. And again, I'll do it with the equal sign so we get a number. 0.85 is bigger than 0.5, so we should be expecting z to be a positive number. We get 1.0364. Okay. I'll do it over here for my x, so I'm still looking at my x being normally distributed with mean 25, whoops, and standard deviation of 10, so I'll put that here so that we remember. So instead, excuse me, instead of norm.s.inv, we're going to do norm.inv. So again, there's no .s because it's not standard. And then parentheses, our probability, still 0.2, but now we need to tell it what our mean and our standard deviation is. So again, probability, then mean, or 25, and then standard deviation, or 10. So we're getting a number that should be equivalent to our z-score if we standardized it. So if I take this number and I standardize it, I should be getting negative 0.842. Again, it's the 20th percentile, which means this value must be smaller than our mean. Okay. And again, this was norm.inv, my 0.2, then my mean, then my standard deviation. And again, for the 85, it's going to be the same thing, except my probability is now 0.85. Okay, so that's what I would type in. So I'll do equals norm.inv, my probability, my mean, my standard deviation. And again, 85% is more than halfway, so that my value here should be bigger than my mean, which it is. Okay, the next four things I'm going to look at, 2 of them have to do with the z-score, so I'll put them over here. And then the other 2 are x values, so I'll put those over here. So z sub 0.30, remember that is the z value whose area to the right is 0.3. What I need is the area to the left. So what I'm going to do is I'm going to do norm.s.inverse of 1 minus 0.3. And I can just put 1 minus 0.3 if I don't want to have to do that math in my head. Or I could do the 0.7 that I know that it is. Okay. So again, I'll do it with the equal sign, norm.s.inverse. I want to be lazy, so I'll do 1 minus 0.3. And again, hopefully this makes sense. If 30% is to the right, then I have to be bigger than the mean, which is 0 if I'm on a standard normal distribution. So I should be a positive number. If I have 65% to the right, then I have less than 65%. I have 35% to the left, which means I should be smaller than the mean. So this z-score should be negative. I'm going to do the same thing, norm.s.inverse, 1 minus 0.65. Or again, I could just plug in the 0.35. So maybe for this one I will. Okay, so equals norm.s.inverse of 0.35. And I do get a negative. If I want the x sub 0.3, I'm going to go over here to my x column. And I will do equals norm.inverse. And I want the probability, which again is 1 minus 0.3. And then my mean and my standard deviation. Again, 30% is to the right, which means 70% is to the left. So my answer should be more than the median, which is also the mean, which is 25. And again, I'll just type in really quick right here what it was that I put in. Okay. For x sub 0.65, again, it's going to be the same thing. I can either do 1 minus 0.65, or I can do that in my head, so it's 0.35, just like it was with the z-score. And again, if 65% is to the right, 35% is to the left, I have to be before the median, which again is the mean, so my answer should be less than 25. And we can see what it is when I actually put in the equal sign. And I do get something that's smaller than 25. Okay, so we're going to be using this quite a bit throughout the next coming sections. So we're going to be doing norm.dist, norm.s.dist to find probabilities because we're using the distribution, and then norm.inv or norm.s.inv to invert the probability and find the z-score. Okay, so we're going to be doing both of these, so it's very important that you remember which one is which. The .dist is the distribution, it gives the probability. .inv is the inverse, it gives back the z-score or the x-score. So play around with it and let me know if you have any questions. Thanks.